Okay, so we just talked about how the chemical properties of elements are periodic because the number of valence electrons is periodic. Elements in the same column have similar properties and they have the same number of valence electrons. Quantum mechanics explains this because the number of valence electrons and the types of orbitals that they occupy are also periodic. So we look at the noble gases. So of course here's helium being a little exception. The rest of the noble gases all have 8 valence electrons. Helium's a little different, but if we think about it, the 8 valence electrons means that floor is full, the S and P are full. This means that the lowest floor is full. It just can only hold 2 electrons. These guys are practically inert. They just really don't interact with anything else because this is just a great place for them to be. This arrangement of electrons is really stable to have 8 valence electrons. And what we're going to see is that other elements react in ways that they can get 8 valence electrons. So I think of these guys as being like the in crowd in high school, that everybody wants to look like them. Electrons are kind of like your clothing because they're on the outside, and the number of protons is your personality. You can't change who you are, but you can change what you look like, right? So here's the alkali metals. These electron configurations are very close to noble gases. They just have 1 extra electron. Mom made me wear a hat to school today because she said I was going to get an ear infection, but this hat is stupid. What are you going to do? Well, let's just take the hat off and now I can look like the rest of the people, right? So these elements will readily lose 1 electron, and then they have a noble gas electron configuration, and now they're +1 ions. And we learned earlier that these guys all make +1 ions. The reason before was because it's in group 1 and I said so. Now we can understand they lose 1 electron because that gives them a noble gas electron configuration. The halogens. So they are also very close to the noble gases, but now they're 1 short. So all of these guys have 7 valence electrons. They want 8. They're just missing that one thing. And so these will readily gain 1 electron. Gaining an electron makes them a -1 ion, but gives them that noble gas electron configuration. So when fluorine gains 1 ion, now he's going to look like his electrons are going to be exactly the same as neon. Does it become neon? No, because it still has 9 protons, so it has a -1 charge. But the electrons are the same as neon, and that's more stable. So this works for all of these predictable charge guys. So why does group 6A form -2 ions? Because if it gains 2 electrons, it'll have the same number of electrons as a noble gas. Nitrogen will gain 3 to get over here. Magnesium will lose 2. Barium loses 2. But why don't we show carbon in here? And somebody asked this question a while ago. Well, what kind of an ion does carbon form? Well, carbon doesn't make ions. To get like a noble gas, carbon would either have to gain 4 electrons or lose 4 electrons. And that either way, it's just too much. So carbon is one of these people that just accepts who they are. I'm just not like the in people, but I'm going to be okay with it, and I'm just going to be myself and rock whatever this is that I am. Right? I'm not going to try to be like anybody else. So that's what carbon's doing.
What is it, boron or beryllium?
That's a good question. We left those off because they're kind of squirrely. Because boron sometimes acts like a metal and sometimes it doesn't act like a metal.
It's on the staircase.
Yeah. Yeah, and beryllium's a little weird too. And I won't try to trick you with those guys.
Does aluminum behave like mercury?
No, aluminum is a metal.
Okay.
Yeah. Because, there has to be an exception to every rule, right? everybody on this, touching the stair step line is a semi-metal except for aluminum.
Oh.
Yeah. Anybody else have any questions? If we look at the electron configurations for ions, we're just adding or subtracting electrons. So here's sulfur, right? 1s2, 2s2, 2p6, 3s2, 3p4. When we get to be a 2- ion, we're adding 2 electrons. So we're going to add 2 electrons to 3p4, and we get 3p6. This electron configuration is exactly the same as argon. With the cations, here's magnesium. 1s2, 2s2, 2p6, 3s2. The metal atom is going to lose all of its valence electrons. Where are the valence electrons? They're in the highest level. We've got 1s and 2s and 3s. So 3, this is the highest level. So it's going to lose both of those. So we chop that off and we get 1s2, 2s2, 2p6. Now it has a positive 2 charge, same configuration as neon. Quantum mechanics explains why magnesium forms a +2 ion.